All right, so now we're going to do a new type of t-test. Okay, it's called a matched pairs t-test, although it follows many of the same procedures that we've done in the past. Now, the only difference is that within each sample, each subject will obtain two pieces of data under most cases, okay, where he or she will be his or her own baseline. Okay, and so here's what we have. I have a small activity where students are supposed to use the handedness difference. Okay, and what they'll do is they will take their dominant hand, put a writing instrument in it, and I'm going to give the students one timed minute where they're going to go to each one of these circles on this paper and put an X through as many as they can. Okay, and they got a minute to do that. After a minute, I'll say stop. They'll count how many they have. A success is making sure that your intersection of the X is within the circle. Okay, and they'll put that value in the bottom here. Okay, and then they'll repeat it with their non-dominant hand. I'll give them another minute. I'll say, ready, set, go, and I'll time it, and they'll go through and do as many as they can. Okay, after a minute, we'll say stop. We'll count the number of X's. Those go there. And once you have those two values, you will subtract and just see what you got. Okay. Now, some people believe, okay, that they are equally good with writing X's with their dominant hand versus their non-dominant hand. Okay. Some people feel very confident with their non-dominant, either hand or foot, with respect to doing activities. Okay. Some believe that you may be a little bit better with your dominant versus not. And what we want to know is, are you going to be statistically significantly better in this activity with your dominant hand versus your non-dominant hand? Okay, so we'll assume for right now that that is no, okay, and that these two will be very close to each other. These two items, the score for your dominant versus your non-dominant. And if we assume that they're very close to each other, okay, that means that the average difference should be close to zero, if that's true for everybody. Okay, so what I'm going to do is I'm going to create a null and an alternative hypothesis where the mu, okay, for your null will be equal to zero. Okay, and remember, we're looking at differences. Okay, it's not how they did on the first score or the second one. It's actually this one on the bottom. Okay, and again, if people did equally well with each hand, then we assume that the difference is zero. Okay, at least as an average. Some people think that the dominant one will be more strongly represented in terms of success, which means, yeah, as you subtract these with the order that we did, that you'll get some large positive number there. And so since we're looking in the positive direction, that means we'll put a greater than sign in that position. Okay, and then what do we do from here? We have to write a definition for mu. Okay, and mu is not the dominant or the non-dominant, okay, representation score. It's the average difference, okay, between the scores of the respective participants or subjects. So I'll write that mu is the true population mean difference in scores. And notice I'm writing the direction, okay, dominant hand minus non-dominant hand. Some may think that's obvious because you did one part first and the part second. You want to subtract in that order, but it's not necessarily true. Okay, so you do have to indicate this direction. Okay, if you don't, then that is a huge no-no. Okay, and you lose points for that. All right, second piece, okay, is looking at our data. And let me just give you an explanation. I couldn't fit this all in one big table. Okay, so I broke it into two. And each subject represents a column. Okay, so this is person number one or subject one, okay, and two and three and so on, all the way to the very end. I believe there's 31. Okay, and what we have in the first row is the respective circles that they were able to put an X through for the dominant hand. The middle row is for their non-dominant hand, And of course, difference is located in the end. And what that means is we took 77, we subtracted 27 as this direction shows for my null and alternative. And we ended up with 50. Okay, now, in all honesty, I didn't do these by hand. Okay, I didn't actually do the subtraction to get this work. I actually put all of these items in kind of like that rust red there in L1. All the dominants went in L1 from left to right, and then from left to right again. And all the non-dominants went into L2. And if it's the understanding that I'll take the dominant and subtract the non-dominants, I did that command in L3. So L3 was L2 minus L1. L3 is equal to L2 minus L1. Okay. And so when you do that, you end up with the differences. And what we want to know is, okay, are these numbers on average either close to zero, okay, or are they statistically significantly far away from zero on average to make us wonder if this original claim about the null is true. Okay, so what I would do, and you don't have to do this for yourself, you can just kind of watch and see. I would put all these in L1 and L2, and then when I have the matched pairs, I'll make my own L3 up. And you can decide which way you subtract. If you want to do L1 minus L2, then that's fine. And actually, I wrote this backwards. I'm sorry. I said L2 minus L1, and it's not. It's L1 minus L2. My apologies. Okay. However, if you want to do it the reverse way, you certainly can. All that means is that your differences will be negative, and then you'll want to switch your inequality in your ha, and then switch the direction in the manner that you did. Okay. I find that most people like to have positive differences. Okay. And it doesn't mean that you may not have differences that include both positives and negatives, but if you find that one is more represented, then certainly you can manipulate the way you choose to subtract and how you write your ha and your direction for your definition of mu. Okay. All right, so that is step one. Okay, again, be careful with the direction and then how you find your differences in your L3. Okay. All right, so once those are done, we have to do conditions. Okay, and so we'll take a look at a couple things. First, just reiterating, this is my L1. Okay, that's my dominant. I'll put a big D there. This is my non-dominant, and then these are my differences, and those are representative of that chart. Okay. If I look at the next piece, I'm just doing a 1-var stats, and I'm doing it with L3, okay, which is what the information is involving. This is different. It's not L1, okay? It's all in L3, okay? And that's the part, again, dealing with differences is which we're evaluating with comparison to 0. All right, and when you do that, you'll find that your average differences, okay, amongst the 31 students is about almost 39, with a standard deviation of 12.366. Okay. Now, what can I do with that? Well, let's do our conditions first, and let's see if I have room here. First, is it random? Do we randomly sample students? And what we did not. This was actually my period 4. Okay. Nevertheless, I want you to look for it. Okay. So I'm just gonna say look for this in your paragraph as you read homework problems or test questions. Okay. Look for this. Okay. And if it says random selection, write it. I bet you it'll be there. Okay. But in this case, I wanted to collect data from my my period, and so because I wanted to do that, I couldn't make students random because I wouldn't have had enough. Okay. All right. Second thing. Oh, excuse me. Second thing is 10% rule, and 31 is less than or equal to 1/10, and it's really all people who can use the pencil. So I'll just say for the most part, all writers. Okay. Anyone who can write. Okay. And I'm certainly way beyond that. The last thing is your large counts for normality. And you're going to ask, is n bigger than or equal to 30? And I think for the first time in any of my videos, n actually is bigger than or equal to 30. It's 31. So by sectional limit theorem, okay, we can say that our distribution is approximately normal. Okay, and again, for sample size of 31. Okay. All right, now let's say that your n was not bigger than 30. You could easily make one of these graphs. Okay, put the little X's in. Or you could do a box plot, and it's easy to do it with this. I think it's pretty quick because you already have the L1 and L2 and L3. However, when you do that command, okay, and you highlight all the pieces that we did before, you can see that we have plot right here on this fourth item here in the bottom right. Make sure you highlight on, okay. The one thing that's unique though is make sure you highlight and identify L3 here, okay. That's where your differences are. Okay, and then when you do that, of course, you'll make that. And again, we didn't really need to do this piece because our n was bigger than or equal to 30. But if you were to fill these in, you do have 16 here. You have 27, 40, 46, 68. This is not meant to confuse you. It's just showing that even when we did it, there was no skewness, there's no outliers. But again, we didn't have to do that. Central limit theorem, because our n is bigger than 30, says that we are satisfied. So all conditions met. Okay. All right. Now, typically, okay, with this information, I can make my t. T is my x bar, which is 38.87, minus the mu. Now, remember from the previous side, and I rewrote it up here, up on the top left, our null is 0 for our population. Our S sub x is 12.366, basically, divided by the square root of 31. Okay. And if you do this math, of course, you're going to get 38.87. Okay. All over. And then this piece here translates to 2.256. Okay. And what does that mean? Well, if your average difference, okay, I usually like to label these, by the way, average difference in scores. Sorry, when I say label, I mean label my graph below. This is 0. Okay. Your standard deviation, if you were to look at this, is 2.256. So this is basically with a mean of 0. Okay. One standard deviation is 2.256. Okay, but you can see that your t is going to be super huge. Okay. So let me do this right now. 38.871 divided by, actually I have it on my phone, gives you 17.2. Okay, which means, assuming the null is true, I'm describing and interpreting a p, okay, or actually I'm interpreting our x bar. Assuming that our null is true, okay, our t value of 17.2 says that our x bar is 17.2 standard deviations above the mean. Okay, so that is our description of t for 17.2. Our x bar, okay, is 17.2 standard deviations. I'm going to abbreviate that above the mean. Okay, very, very big. Degrees of freedom is n minus 1, n again is 31, minus 1 is 30. All right. So what do we do with this? We typically do a TCDF. We can do that. That would indicate that, again, if I were to draw, okay, and this isn't scaled right, 17.2 is how many standard deviations we are away. However, I'm going to draw 38.87, excuse me. Okay, and then shade to the right because I have a greater than for my ha. Yeah, we're going to have a really, really small number here. Okay, now remember for TCDF, while this is a good drawing for my sample mean average and the population mean average, which is supposed to be 0, we're standardizing this to t, where again, we're still going to have a 0 here, but I'm going to use my t representation here, which is 17.2. I'm going to put in my upper bound, which is 1,000, and my degrees of freedom is 30. Okay. And again, this is a super large test statistic. In fact, usually when test statistics are over 4 or 5, you know that when you finish these problems, it's probably going to give you about a value of 0. Okay. But I'll do second TCDF just real quick, because this is kind of handy. 17.2 and then 1,000. And my degrees of freedom is 30. So I don't think I had a screenshot for that. I'm getting 2.18 times 10 to the negative 17. Okay. And so that again is super small. Say that. Oops, sorry. Let's make this a P. P is basically about 0. Okay. And okay, that's enough to help answer this question. Okay, in terms of whether we reject or not reject the null. Okay. And so what I'll say is this, since my p-value of about 0, and I'll make little approximations, is less than an alpha cutoff of 0.05. Null. Okay. And what does that mean? It means there is evidence to suggest that, okay, and then I'm going to go back to this down here. I say down here, but it's really down below the null and the alternative, which is the mu. The true population mean difference in scores okay, is greater than 0. And then once again, I'm going to indicate the direction. Okay, I'm going to say the dominant hand okay, minus the non-dominant hand. Okay. All right, and that is officially done. Okay. If you want to use your TI-84 graphing calculator to do steps 3 and 4, here's a quick way to do it. In fact, it's the way I would encourage you to do it. When you have a list here, first of all, go to ttest. So you'll go to stat, and you'll go to test, and you've got ttest. Okay, and how do you get ttest? It is 2. Okay. And all your data is in your calculator. Make sure you change the mean. People oftentimes will forget to put that in there, and they'll leave the 0 as it is. And don't forget that you have to change this to L3. Our last one is L1. Okay. Keep that in mind as you do tests later on. You may have to go back to using L1 again. So this constantly gets moved, okay, from L1 to L3 to L2. Adjust that accordingly. And then, of course, afterwards, we will go to calculate. Okay, and again, notice the t value was super big, 17, and I had that same proportion that I had shared earlier with my TCDF, okay, which I didn't have a screenshot of, but I said it was to the negative 17 power. So remember this, when you write your P, you really don't have to write this part, okay? Again, this E means times 10 to the negative 17. At this point, we kind of know that's basically 0, okay? And so you're invited to write it that way if you like. You don't have to write all this. Please don't just say P is equal to 1.3597, okay? That's frustrating to everybody because P is not anything more than just a proportion, and proportions cannot be bigger than 1. And so when you write this, you're kind of indicating that you don't understand what this means. Okay, so don't do that. Either write the whole scientific notation piece that they give you, or just make a good judgment. Okay, that's yeah, when you have this, that means 10 to the negative 17 means you fly left with this decimal 17 place values, which gives you basically about 0. Okay. All right, so I hope you like that calculator command. I would do that every time just because we're loud. And as long as you write TI-84, ttest, okay, then make sure you write your your T, excuse me. Make sure you write the p-value, okay? I always write degrees of freedom too, just because I think that's easy. Okay, you'll get all the credit for 3 and 4, as long as they're accurate. Okay? All right, hopefully that's helpful. You only have 2 questions on your homework related to that, okay? You can see that they're marked here. Okay, 73A for right now, that's the first one that has all 5 parts. Okay, where you have to do the null, the alternative. You have to write a good definition for that, the null, in terms of what mu may be. You have to write the conditions, make sure you include all 3 parts. Give me a test statistic with T, give me a proportion, and then give me a good conclusion, okay? Everything before this are like pieces of those 5, okay? So look for that. Know that you don't have to do all 5 parts for those, okay? These here, 73 and after are a little bit more involved where you have to do most of the homework pieces for all 5 steps, okay, in terms of a test and the first test. And then again, these are the new ones, okay? Make sure you label again how you're going to do your subtraction. Is it L1 minus L2 or L2 minus L1? Are you gonna make a greater than sign or a less than sign? It could be times when you have a not equal to. Just depends. Okay, and then of course these last 4 I think are multiple choice. That doesn't mean when you have multiple choice that you shouldn't have to write stuff down. A lot of multiple choice questions have work that you should show with it in order to get the answer. Okay. All right, if you have any questions on 9.3, you let me know and I'll be happy to help you out. You have a great day.